Hello friends, this video on relations and functions part 25 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 24. Let's take one example. So let A and B, we have to show that the function A cross B to B cross A such that f of AB is equal to f of BA is a bijective function. So here if you see, this is the example, this is my domain, codomain. I won't solve using that method, but I'm just trying to show you what is the question. This has A cross B values and this has B cross A values, and there is a mapping here. If it is AB here, this becomes BA here, correct? And we have to prove that it is a bijective function. To prove it is a bijective, we have to prove it is 101 and on top. So to prove it is a 101, what we do, we say that we assume f of x1 is equal to f of x2. Assume, and then we prove that x1 is equal to x2. If we can do that, that means it is a one-on function. As I told, this is x1, x2, fx1, fx2. If you can prove, if I can assume this is equal to same, both are same, then this has to point to same number. So this has to be same also for this to be 101. You can refer my last example if you have doubts in this. Now, if you say f of x1 is equal to x2, assume, then I can say that f of a1 b1 is equal to f of a2 b2. This is my assumption. F of a1 b1 is nothing but b1 comma a1, correct? And of f of a2 b2 is nothing but b2 comma a2. This is my assumption. So with this I got this, because f of ab is ba, f of a1 b1 is b1 a1. Now with this I can say that b1 is equal to b2 and a1 is equal to a2. If you compare these two, I can say that b1 is equal to b2 and a1 is equal to a2. Now to prove that, so to prove that this is 101, we have to prove that a1 comma b1 is equal to a2 comma b2. Since a1 is equal to a2 and b1 is equal to b2, we can say that a1 comma b1 is equal to a2 comma b2. Correct? Why? Because if you compare these two relations, I got b1 is equal to b2, this section, and a1 is equal to a2. Since b1 is equal to b2, a1 is equal to a2, I can very well say a1 comma b1 is equal to a2 comma b2. Since I have proved that a1 b1 is equal to a2 b2, where I have assumed that f of a1 b1 is equal to f of a2 b2, I can say that this function is 101. One part is done. Now to prove it is on to, what did you say? For every y, there exists x, right? That is the definition we get. So for this problem we will say, because the problem here is f of a comma b is b. So we can say that for every b comma a that is member of b cross a, there exists, for every b comma a member of b cross a, there exists a cross b that is member of a comma b that is member of a cross a. So we can prove that for every b comma a that is member of b cross a, there exists a comma b that is member of a cross b. That means it is an onto function. If we can prove this, correct? Because we told that for every y there exists x. If that is true, it is onto function. So as per this question, for every b comma a that is member of b cross a, there exists a comma b that is member of a cross b. In that case, it is a onto function. And if you see this, by definition itself is true. The definition says there are two sets where A cross B is B cross A, such that f of AB is equal to BA. By definition itself it is true. This is true by definition itself. So we need not prove anything, because definition itself says that this is true. Since this is true by definition, we can say that the function is onto. Since the function is 101 and onto, this function is bijective. Right? Function is injective, 101. Function is surjective, onto. Sur is there is no orphan. And since it is injective and it is surjective, it is bijective. Please pay attention here, little tricky question. To prove it is injective, we prove that we assume f of a1 b1 is equal to f of a2 b2, and then we prove that a1 b1 is equal to a2 b2. We prove it is injective. To prove it is surjective, we have to prove that for every b comma a that is member of b cross a, there exists a cross a comma b that is member of a cross b. This is true by definition itself. Thus the function is surjective or onto. Since the function is now injective and surjective, it is bijective, because we told that bijective is nothing but function that is injective plus surjective. Correct? Injective is nothing but 101 and surjective is nothing but onto. So if the function is injective and surjective, that is 101 and onto, it is bijective. Let's take one more. The question says let A be real number minus 3 and B be real number minus 3 sets. We have the function from A to B, though there is a function from A to B. This is A, this is B, and A is nothing but all real number minus 3 and B is nothing but all real number minus 1. It is defined by f of x is nothing but x minus 2 by x minus 3. We have to prove it is 101 and onto. So as I told, for function to be 101, let me solve it here only. For function to be 101, we'll assume f of x1 is equal to f of x2, and then we'll try to prove, x1 is equal to x2. If we can do this, then the function is 101. So we can say that f of, let's do this, f of x1 is equal to f of x2. Let's assume this implies x1 minus 2 by x1 minus 3 is equal to x2 minus 2 by x2 minus 3. Correct? So let's solve this, multiply this, x1 minus 2 into x2 minus 3 is equal to x1 minus 3 into x2 minus 2. Solve this further, you get x1 x2 minus 3x1 minus 2x2 plus 6 is equal to x1 x2 minus 2x1 minus 3x2 plus 6. Plus 6 plus 6 cancel, x1 x2 cancel. So what you get? X1 you take this side, you get minus x1 is equal to minus x2. Correct? Or you get x1 is equal to x2. Thus we have proved that it is 101. Why? We assume f of x1 is equal to f of x2, and then we prove that x1 is equal to x2. So it is 101. That is done. Next is onto or not. For onto we told that for every y, if it is x to y function, assuming that for every y in B, for every y that is a member of B, there exists x that is member of A. Correct? For every y that is member of B, there exists x that is member of A. So we have, if you take function is nothing but y is equal to x minus 2 by x minus 3. Hence, if you take x here, y will be nothing but f of x. Correct? Y is nothing, f of x. F of x is nothing but x minus 2y, x minus 3. So we say y is equal to x minus 2y, x minus 3. So let's write y in terms of x, because for every y we have to find x exists or not. So if you do this, you will get x as nothing but 2 minus 3y by 1 minus 4. You can try this on your own, you will get the same thing. You just say yx minus 3y is equal to x minus 2. Solve it, you get x is equal to 2 minus 3y by 1 minus y. So if you see that for every y except y is equal to 1, there exists x. The moment you say y is equal to 1, that becomes 1 minus 1, 0. Some number by 0 is infinite, it is not defined. But to take any number y that is not 1, for that you get 1x, that is for every y that is part of real number but not 1, there exists x that is real. And if you see, that is what we do prove. For every y that is part of b is nothing but r minus 1. For every y that is part of set b, that is real number minus 1, there exists an x that is real number minus 3, real number minus 3, real number minus 1. Correct? So that is what we have got. Thus we have proved that this function is onto function. Why? Because for every y that is part of real number minus 1, there exists an x that is part of real number minus 3. X is equal to 3 is not there. Why? You see, when you write y in terms of x, x minus 3 comes in denominator. The moment you say x is equal to 3, this becomes infinite. So anyway, x is equal to 3 won't come. So for every y that is part of r minus 1, there exists x that is r minus 3. Thus it is onto function. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.